Hey guys, welcome back to this fantastic tutorial presented to you by one of the most best online learning platforms, Eduonix. Let's get started with the fundamentals of blockchain technology. We have understood what is blockchain, what are cryptocurrencies as well, seen the problems with the current financial system and possible solutions regarding those problems. And blockchain is one of the biggest solution for the current financial system. So let's see how blockchain works with the fundamentals of blockchain, and the first one is hash function. So what is a hash function? Here I have listed the properties of hash function, but what is exactly a hash function? In a very simple definition, hash function is a function which converts data of any size to a fixed size. Now whether you have data of 1 terabyte, 2 terabyte, 1000 terabyte, any gigabyte, megabyte, it will convert to a fixed size. If you Google the list of hash functions, not hashtags, but list of hash function, you can see there are lots of hash functions available. Non-cryptographic hash functions, key cryptographic hash function, unkeyed cryptographic hash function. So what we are going to use is the unkeyed cryptographic hash function and the SHA-256 hash function, which is used by Bitcoin. So hash function is just an inbuilt function which are available in many programming language, mostly inbuilt, but sometimes you have to import the library. In case of Node.js, you will have to import the library for the hash function. So these are the listed hash function. The Ethereum blockchain using SHA-3. Normally developers use MD5 to hash data passwords of users while registering on a particular web app. So these are the list of hash functions, and as you can see, what SHA-256 does is it converts data of any size to a fixed size, that is of 256 bits. Now the data can be of any size. It can be of 1 terabyte, 2 terabyte, as I have already said. It will convert it to 256 bits. The conversion will be in alphanumeric, basically 384 bits, 160 bits. So let's see how hash function works. What I'm going to do is I'm going to show you practically as well. So this is basically my Cloud9 IDE which I'm loading right now. So you can register on Cloud9. It is recently bought by Amazon. So one user is free, but you have to give your credit card details. But no worries, they won't cut anything from your credit card for only single user. So you can sign in with Cloud9. One single user is free. It is basically an integrated development environment, a web-based IDE. So you can access your code from anywhere around the world. You don't have to worry about taking your data with you always. So this is how it looks. I've already imported some of my project here. And this is a file sign.php. Since I am quite familiar with PHP, what we are going to do is we are going to use PHP to use our hash function. Now many of you might not be PHP developers. You don't have to worry. Even if you are a non-developer, I'll keep my syntax very easy so that even a non-developer can understand. So the first property of hash function is it's collision free. Given an input A, it should be difficult to find different input B such that hash of A is equal to hash of B. Basically, hashes are unique. The basic conclusion of the first point is that hashes are unique. So if there are two hashes which are same, we can easily say that the data coming from the two hashes are also same. So let's see how I can justify my statement. I'll just remove some, just make some syntax correction. So what I have done here, I'm just creating a variable with a string called hello world. Okay, you can give space also, hello world. Now this is just to print our data on the web browser in the next line. That's why I'm using echo br, and then I'm printing my hello world. Okay, I was storing some data, I'm printing it here on the web screen. I'm going to use echo for that to print any data. Then again I'm going to give a line break, and then I'll hash my data and print the hash. So let's run this. I also have a PHP Apache server in this. So as you can see, the hello world hash is this one. You can also make it like, okay, to be precise, it is a hexadecimal here, and the date, this is our data, and this is the hash of our data, and it has converted this data into a fixed size. I don't know how much size is hello world, but basically it has converted to a fixed size of 256 bits because we are using the SHA-256 hash function. If I increase the size of the data, you will see that even after increasing the size of the data, just printing it like as many times I can, the hash size remains the same. So as the definition which I had mentioned, hash function converts data of any size to a fixed size. So even if I increase the data, it is converting it to a fixed size. Now the first property is collision free. So I'll show you how we can define collision free. What we'll do is we will write one more data, hello world, and we'll write underscore one, just like exclamatory, not underscore one, exclamatory, and we'll print this data as well. We'll name it data one, and then we'll hash this data. Now let's refresh the page. So as you can see, the first hello world hash is this, and the second hello world exclamatory. The only difference between this string and this string is the exclamatory mark. But as you can see, the hashes are entirely different. So we can easily conclude that if these two hashes are not same, then the the data of the hash is also not same. And if these two hashes are equal, we can easily conclude that the data is coming from the hash is same. To check that, we can just remove the exclamatory mark. So as you can see, the data of the two hashes are same. So if you are just given two hashes, you are not given data at all, you are just given two hashes and you don't know what is the data. But these hashes, you can at least conclude that the data which you have got is the same, is equal. So that is the first property of our hash function. Now we will continue with the second property in the next video. I hope you have enjoyed our video. See you next time, guys. Bye. Welcome back, guys, to this fantastic tutorial presented to you by one of the best online learning platform, Eduonix. So previous video we have studied the first property of hash function as well as what is a hash function. The first property we saw was collision free. Now the second property is called hiding. Let's see what is hiding. Property of hash function. A hash function h is hiding if when a secret value r is chosen from a probability distribution that has high entropy. Then given h r concatenated with x, it is infeasible to find x. So let's see what's the meaning of this. What is the meaning of high entropy? I'll explain you in a while. So previously we saw the first property here. So we'll just remove the code of the previous part. So when I say hiding, the hiding property of hash function, the easiest way to explain is if I give you a hash output. From this output, it is impossible to find the data which has been hashed. But nowadays, we have hackers who have become quite smart, and while we hash the data of any end user, especially while storing password, when we hash the data, but the password stored by the end user is pretty weird, or I would say very simple. I can give you my own example. When I was a teenager, I used to store password like password only, password as password. So what happens is hackers have something called a rainbow table. You can study about the rainbow table in your free time. It is not a huge part of the blockchain, not also in the blockchain curriculum, but just for explanation purpose. So what is a rainbow table? As I said, hackers have this rainbow table in which they store all the possible password an end user can create. For example, something like password itself, or someone might just write I love New York, okay, or I love India, I love you, and it's some simple. These are the password which are coming to my mind right now. But some simple password which are very easy to crack. Okay, even though as I said, it is not easy. It is almost impossible to get the data from this hash. But hackers have something called a rainbow table through which they can just predict some data, and that data might be equal to the hash data. So what we can do is we can create something called a random string. Random string. Now this string is really random. It can be like anything, numbers, symbols, space, or anything. It is a random string. And this random string is concatenated basically. We'll concatenate the random string with our data. Random string. We'll print it on the screen. We need to break the line for better visual purpose. So this is our real data, and what I have done is I have concatenated with a certain random string or random data, you can say, and then I have hashed it. So as per the second property definition, a hash function h is hiding if when a secret value r is chosen from a probability distribution that has high entropy. Now what does this mean? From a probability distribution that has high entropy. So with this I can give you an example to explain this sentence. Now if I give you a coin has two values, one is heads and tails. And if I basically I give you two hashes, okay, and I say this hash is these two hashes are the values of a coin. So with values of a coin, we know a coin have only two values, one is heads and tails. So we can easily, by trial and error method, we can easily get the hash output. Okay, and we can easily match which hash belongs to heads, which hash belongs to tails. But when I say high probability distribution min entropy or entropy, if not min entropy, just entropy, it means from a very high space, high distribution space, that random string can be anything. It can be someone's name, it can be number, it can be color, it can be name of a place, name of animal, or anything which is very random coming from a high space, not from just a set of values like coin, which has only two set of values. So it's coming from a very high min entropy. That's the meaning of this statement. So this random string is not predictable. Okay, it is coming from a high space probability distribution entropy. And what I am doing is, with this random string which is coming from a high probability distribution entropy, I am concatenating this string with a main string, which can be password or anything. And after concatenating it, then I am hashing the data. So what happens is, it gets next to impossible for a hacker to get the core data from this hash. So I hope you have understood the second property, that is hiding. And the third property we will continue in the next video. Hope you have enjoyed this. See you next time, guys. Bye. Hi guys, welcome back to this fantastic tutorial presented to you by Eduonix. So we have been going through the first fundamental of blockchain, that is hash function. We have seen what is hash function and the properties. The first property is collision free and the second property is hiding, which has been covered in the previous two videos. Now let's go to the third property of hash function. The third property is called puzzle friendly. For all probable output B, if M is chosen from a high spread probability distribution, then it is not feasible to find the value A such that hash of M plus X is equals to A. So this third property is very much similar to the second property, but obviously there is a slight difference, and the third property of hash function is used in proof of work, the mining of Bitcoin. So let's understand the third property. What I have done is I have just removed the hash. So as for example, if you have the X, okay, if you know, now in this situation, if you just know the input data, okay, the input data, that is password here, but you don't know the random string, okay, you don't know what is the random string, but you know the input data. In that situation, it is not feasible to find the output hash if you don't know the random data. That's what it means. And this random data is coming from a high space, from a very high spread probability distribution or high space probability distribution. So it is infeasible to find the hash output of this data because we don't know the random string here, from where this random string is, basically what the value of this random string is. So this is the third property of hash function, and the third property is used in the proof of work algorithm of Bitcoin. In the next video we will continue with the second property of hash function, that is digital signature.